Okay, let's get a little bit of streaming done here. So I want to see if I can make this actually work the way I want it to. So let's see here. I'm just going to hop right into it because I've been working on this already this morning. Let's do prep. I want to def B. Still takes a while. That's part of the struggle I'm having. Although it's decent, it's not too slow. But now if I do matrix mget, not there we go. From B, yeah. Wait, what? It's a mistake to print that to the REPL, obviously, but well, that's fine. It's getting a little slow here. There we go. We're kind of better off. Yeah. Right. I should actually do M shape of B, 401, 401. Let's just, I think this is unnecessary. Let me do that. Oh, I forgot to, I should have done time as well, but that's okay. Okay. Right, so now what I kind of want to do is let's M shape B. Yeah, 400 by 400. That's exactly, that is what I want. Now, if I want to see if I can def C as M emap mutable render 0.2 over B. Yeah, see, that was nice and quick actually. And let's do mget from C 100 100 10 10. No. They shouldn't all be nil, I hope. There's one. Okay, so it's not all empty. That's good. Okay, so these two functions work. Prep grid and render the grid. They all work. So there's just something going wrong here. Oh, I think I need to wrap this in a when. Yeah, when data is m/mget from pixels xy. So you get the pixel from, actually let's just call this a pixel like that. It's wrapped in a let, so we gotta do this. Yeah, so when from pixels there is data there, right? Then yeah, so it's like this, pixel. When pixel, do that. Okay, that maybe should speed things up a little bit. Let's try it. Cider show 2a. Let's first of all see if it actually renders at all. It hopefully should. Oh no, there's a bounds error. Why would that be? I don't know what's happening. I don't think this... So there's also design problems at the moment where I've just got hard-coded values in these spots. And that's not really what I want at the end of the day, but we'll get through it. For that, let. There we go. Okay. I am confused by this. It's very possible that I'm just missing something here. I mean, in fact, it's pretty much inevitable that I'm missing something. Yeah. Well, let's just back things off a little bit here. Render filter sum, show render. Let's just see if things are working at all. First render. Right? Cider show 2a. me just sanity check this. Using the cider show that I had yesterday, this should render A. It's a hexagon. It should work. Well, maybe that's the problem. It's just not working. A. No, it should work. Okay, I've messed a few things up apparently. Oh yeah, so this here, this format is not correct for this render function. These points are actually like this. It's point distance like that. Yeah. So cider show uses prep grid render point version 1. Yeah. So this should work now, I hope. Cuz we need some reference to work off of. There we go. That's not even too slow, honestly. It's pretty good. And it's just fuzzy because of the radius I have here. I can unfuzz that. And that'll work okay. Boom. Bing, bang, boom. Right, so that's the no matrix stuff there. I'm trying to learn the matrix, like the array programming stuff, just well enough to see if I could actually get speed improvements. I don't know what I'm doing. That's part of the problem. Yeah, so here I'm trying to architect this in a way that is helpful. So B, right? If I do shape of B, oh, M/shape of B, it is 400 by 400 and it contains data. I know that already, right? And if I do M shape C, it's the same thing. It already does contain data. Which if I so let me think about this. Filter slices. It's cool, but not what I need. Oh, it does work. Kinda. Oop. Um, hmm. Oh. Oh. Here's the problem. Okay, I figured it out, I think. So if I do m/mget of c, -1 is out of the range. So okay, so this, right, has to be, the range has to be the shape. That's all it is. That's the whole problem. Okay. So this has to be 400. So it goes from 0 to 399. Yeah, that's got to be it. There we go. Hopefully that fixes my issue. Then of course it just remains to be seen if it's actually faster, which I think it's not. But let's see what's up. Okay, so this should render successfully, I hope. Hey, that worked. So now I'm actually wondering if there's an even faster thing to do, if there's a faster way to build this up. So right, so the let's make let's see here, m/array implementation nd array, so that I can do fast mutability stuff with it. And then the data, there's got to be a m/empty fill. Let's check some of these docs here. Matrix implementations. Okay, well, let's go getting started. One thing I like about Core Matrix, it works in Clojure script, which is important for me. At some point it'll be necessary that I do stuff in Clojure script, so right, sorry about the occasional distractions. It's a Friday and I'm getting messages here and there, so really should put my phone away, but I don't know why I don't. I'm just trying to find make an empty functional operations on arrays. Oh, eReduce might be... No, that's not exactly what I want. I'm not going to worry about the vector z stuff. at the moment. Views, let's see what this is. Oh, new matrix is, let's see here. M/new. What's the difference between a matrix and an array? Mutable arrays. I wonder, is a matrix a superset of an array? So matrices are built on arrays? I don't know. Set. Object array. I unfortunately don't know what I'm doing. That's part of the trouble here. New array. Implementation. ND array. And then the shape is 400 by 400. Oh, I should def this. Just it's lovely. It's all empty. I keep forgetting that it's not wise to print huge matrices to the REPL. Or I keep thinking that it'll be flawless, but it's never flawless. There's always something going on. Okay, so See, what I want is I want to fill an array with a function that is an that's a with a the result of a function of its position in a 2D array. Um, Sequence wrapper of JBlast. That's not what I want. I don't know. Let's see. Well, let's just keep trying to learn. Class. I don't. The class doesn't matter to me. Really, it might. Maybe it does. I don't know. Linear algebra is not exactly what I need here, but singular value decomposition. Above my head at the moment. No, these aren't exactly helpful to me right now. See, something like this here, using an implementation that actually runs on a GPU might ultimately be what I need. But I want something. It doesn't have to be the most fast thing in the world, but it has to be usable. And I don't want it to be complicated. And I wonder if those just end up, I wonder if that's not possible. Like I just have to deal with it somehow. Well, let's see here. Core.matrix function of, let's see. Let's see if there's something useful here. Walk. Yeah, I kind of think I'm not really going to get much improvement from what I've got now. However, let me just think about it one little bit more. Yeah, so basically this is, I think, probably as fast as it'll get. Let me do something here. Time prep function grid. So this, oop, that's not what I meant to do. Here, let me wrap this in a do this, and then print line done. So it doesn't fill. No, that can't be right. Oh, here, this is why. It's not actually, not sure if this is right. There we go. .7 seconds on that one. This one, it's slower. I don't know why. I guess maybe the default implementation of ND array using the Clojure data structures is just guaranteed to be slower. So let's not do a mutable map. We'll just do a normal immutable one. Core matrix. Okay. Maybe some examples are helpful. Just a regular Clojure value. Yeah. Matrix constructors are provided. Identity matrix, pretty print. Oh, that's probably a little bit helpful. You can do some functional stuff with it. Yeah, so this is what I'm trying to use. Scalars. That's all good. Oh, scalar array. Maybe that's... No, sorry, that's not what I need. Vectors versus matrices. A slice of a matrix is a 1D vector. Yeah. So I guess the intent... So it looks like what I actually want to do is hydrate with this parallel, like with just normal Clojure stuff, and then turn it into an array at the end, kind of thing. So let's try that for a moment. Now that is what I'm doing. That's not saving me any time. Huh. Oh, this is... Wait. If I do this now, this, I think I messed up the shape of this. Right, if I take this now. So M, shape of B, yeah. But if I do M shape of prep function grid 2 now of, let's keep the numbers small so it's a quick calculation. I think the shape will be wrong. Yeah, I've put it all into a flat. I need this to be back the way it was before. Yeah, so let me we'll call it an index grid. I don't know if that's like a valid thing, but that's what it is, I guess. Yeah, so you just pop it all into an array like that. Right, so let's actually do index grid let me just double check here. Let's force a do run on this. Okay, so populating the grid like that is super quick. Now what I wonder is if I do, so I can make a whole grid like that. Then what I want to do is emap over that grid. This is maybe a bad name for it, but all I'm doing here, so I'm populating an array with maps of x and y, and then I want to just wrap an FREP function in a way so it has to return a function taking a map that has keys x, y. Then right away it just does FREP XY like that. So it's just a little helper to turn this into the normal FREP way. So let's def b now as index grid boom, nice and quick. So shape B, M shape B, my bad. 400 by 400 is exactly what I need. Now what I want to do is def C as M emap array FREP of A, map that function over B. Well, let's actually check if this works. Array FREP of A. Yeah, so, right, if I do A00, 0, I get, ooh, let's change that so I see a bigger number. There we go. But now if I do this won't work. I need it to be a map now, like this. X100, Y0. There we go. Okay, so it works. So array FREP is working. It returns a function that takes the map. Right, so this ends up being the slow part. And I bet that, because now if I def D as, oh, I actually want to time this. Because if I do, what I want to see let's redef B. It's now mutable. So my thought is this would be faster, but maybe it's not. It's not appreciably faster. It's the same. So clearly my understanding is wrong. Can you tell I'm just ready for the weekend and looking to just wishing this worked, you know? I want it to work like that. That's what I want. And well, it's just not doing that. That's the thing. Well, what if I just so if I do a right, so doing this, oh, I don't know. man, I'm running out of ideas because I'm at the edge of my understanding of what's supposed to be fast and not, right? That's the trouble. One of the troubles I'm having. Um, what I think is there something like index. I'm not sure what that means. An index is another value type or data type, I guess. Oh, emap indexed actually might be exactly what I need. Let's do emap indexed identity. And let's just do a super simple 1, 2, 3, 4, 5, 6. Hey? Oh. It's a 2-argument thing. So I have to do identity. Let's just do this. Am I being smart today? Nah. Identity 1. Oh, wait a minute. I don't need to even, I could just do this. I don't know why I'm trying to get all clever here. 1, 2. So how does this work? It gives me the index as a list and then the value in that position. So I can actually just use, yeah, so let me try. Let me try this. Array FREP. I can actually, let's just change this whole paradigm. If I do map indexed, I can do this. Is it better? It won't save a ton of time at the end of the day, but it'll look like this. I could do point. Yeah, so now, right, now if I were to do, let's pop back, let's def b as index grid. Let's 100, 100, 100. Okay, so that's a mutable array. Now what I want to do is def c as, oh, let's time it. Time def c as emap indexed of array frep of a over b. Oh. Oh, I have to. am I doing wrong? Oh, it's right, I'm being silly. That's wrong. So passing 2 arguments into the function, this, I destructured it incorrectly. It'll actually just be this. So that should fix that. Whoa. Okay, so that was actually faster. Let's do first of first B. Wait, what did I def B as? Oh yeah, I don't need, I can def B as m/new array nd array, and the shape is 200 by 200. Oh, There's a slight issue. Because if I do, well, let me get to the, oh, the reason this is quicker, I know why it's quicker. Because it's a smaller array. That's a bummer. Right, like if I def B as a size 400 by 400, it'll be slower again. Yeah. Okay, so we're not getting anywhere with this. Well, let me finish setting up the functions to build out this structure. Then maybe I'll see if I can install a fast implementation. See if I can get anywhere with that. Because that'd be fun, at least. At the very least, if you've got a Java, a JVM only implementation that's quick, that's better than nothing. And then if you can use the same stuff that's not quick on Clojure script, you're still using something. Hey, Chadwick, how are you? I hope you're doing well today. I'm having a casual Friday going on here, you know? What are we working on today? Well, I have, what's the quick way? Okay, here's the quickest thing. I made a really rough and dirty method to display some of my functional representation elements in the REPL here. So I have this function that I made, cider-show. I can explain what it is in a minute, but you can see, so it's calculating something, and if you give it a second, it'll actually render out a shape into the REPL here. But you saw how long that took. So I'm playing around with Clojure core.matrix. I've never used core matrix before, so I'm just trying to wrap my head around how it works in general. And I'm seeing if I can use that to build out a sort of faster way to render these things into the REPL like that. That's what I'm working on today. Feel free to ask any questions. So what I showed you there is this cider-show function renders A. So obviously I got to explain what A actually is. So if I just eval A here, it is a function. It's a functional representation of a shape. So it works this way. It expects, because it's a 2D functional representation, it expects a 2D point, and it will give you a number back. So if I do 100, 0, it's got this positive number 20. And FREP, it's literally just giving you the scalar distance, that whatever point you pass in, it's giving you the distance from that point to the nearest the nearest part of the edge of the shape itself. And then you can use that function to render out each pixel, and then change the color of the pixel based on the distance value. So if the distance you get is exactly 0, you are sitting exactly on the edge of whatever shape you pass in. That's the whole idea. It's pretty simple, but rendering that out is what I'm working on here. And my approach is, it's naive because I don't mean it to be like this is how you use it. It's just sort of a handy REPL tool, if that makes any sense. It's based off of a few different ideas. So I've got, if I go into this handy dandy Scratch namespace, I have a few different shapes here. So I'll do this as a simple example. This is a cylinder. It's a circle of radius 20, and you extrude it 100 units. And I can show, I can also eval B, so I can show A and B. This is using a different mechanism, but so these two, right? So show A and B. You see how much quicker those were? This is actually sending off, like it's shelling out to another program, OpenSCAD, that actually is doing the 3D render and saving a PNG, loading the PNG back into the REPL. It just happens quick enough that it's like, it's not too disruptive for your workflow if you're using it in the REPL. So I want that kind of feedback for the functional rep versions of these things as well. These versions here, they're a bit different. They're not a function. If I print A out to the REPL, it's just this. It's just a tree, a simple tree structure, right? So I've got the revolve operation, wrapping a translate operation, wrapping the circle. Then the SCAD here, it uses a writer, SCAD/write, to compile OpenSCAD code. So it's extremely lightweight on the Clojure side, and then it's sending this code off to another program. That program does the calculation, spits back the PNG. The whole reason for this design is you want to use the tree structure to emit different target languages, right? So I have a work in progress one for another tool called FreeCAD. I want to make ones for SolidWorks, that sort of stuff. So it's all working, it's all starting to work better and better. But I also want the functional representation stuff to be a part of the internal representation, because those functional representations are really useful for things like calculating if a user wants to slice at an arbitrary plane. It's really useful. You can slice it, then you get a 2D functional representation from a 3D, and then you can render out the 2D slice, use that render to derive other data from. So it's really helpful to have all that. But to make sure I'm building these tools properly, I want visual feedback. And in 2D, I can be a little bit patient, but it just is way too slow in 3D. For anything complicated, it just is way too slow. So I'm trying to wrap my head around a few things. Concurrent and parallel stuff, and now matrix stuff, just to try and see, without really delving into like this is how you make fast code. I just want to see with the default tools how much faster I can get beyond the naive implementation. Hope that makes some sense. That's what I'm working on. See, the thing is, like, I don't technically need any of these tools to be able to continue forward with the library I'm building. It's just I feel like it is important to wrap my head around these things enough, because the ideas behind this will obviously be useful for a real renderer at some point. And I don't want to just shell out to external programs for literally everything, because then it's kind of a cop-out some of the time, you know? Anyway, that's the long-winded explanation. I hope that makes some sense. Feel free to ask any clarifying questions. Yeah, that's what I'm working on at the moment. Right, so I wanted to finish off right, so A is that function. Cider show works. Cider show 2. Oh, this might break. I don't remember what the state of things were. If it works, it's an exploration into this, yeah, numbers not mutable. Right, I've been changing things around. It's gonna break. I'm trying to make a version of the showing function that uses mutable arrays to see if I get actual improvements, and so far I haven't, but that could just very well be that I don't understand how to do it properly yet. Simple as that. It might just be a blind spot. Yeah, hopefully that's a bit helpful to you. Right, so where was I in my thinking? I was let's change this up. Let's make a grid that's just m/new array, nd array, and the shape of it is just going to be we'll do 300 by 300. Just keep it a little smaller, you know. No reason really to do that, but you know. But so that's the grid, and then what I actually want to do is pixels. I don't know if this is a good idea or not. We'll find out. Let's map over the grid. Oh, sorry, m/emap mutable over the grid the function. Wait a second. I can comp. I don't even need to do it. I don't even need to thread it. I can comp it. Comp. Render point. Emap indexed. Actually, I don't know if this will work, but we'll find out. So the first thing I do is run the function array FREP of A. Then the second I did this wrong. comp those two functions together and map that whole thing over the grid, and then you get the pixels, hopefully. And then here, right, so this, I can make this better too. I can make this actually a function, an array. If I make it an indexed thing again, I can do point distance. And then here, translate point. Right, so make your grid, comp these two, and then you should be good to go. Let me see. Let's just comment out render for the time being here. When not empty pixels, show pixels. All right, let's see if this is gonna work. It might not. Wrong number of arguments, one argument passed to render point 2. Yes, and that's because yeah, okay, so I can't quite comp that because, well, let's see if this works at least, and then I can think through this, because I think I might actually get benefits from trying to do a comp, because then it's what's the word? A transducer, right? And if it's a transducer, it can do the entire transformation on the individual part in one go, instead of internally building up and breaking down a bunch of data structures. Oop. But to make sure the logic of what I'm trying to do is making sense, let's pass a grid through map indexed of first array FREP of A. So you map that function. Oh, this has to be thread last actually, because you're mapping this function over the grid, and then you do map indexed again over that new index, or that new array, I mean, the function render point 2, and that'll get two values passed in, the point and the distance. Oh, yes it will. Yes it will. So that's your pixels. Let's try that. If I use the right symbols, you know, maybe my programs would work better. Let's give that a shot. Okay. I'm gonna let that go, and I'm gonna go to the washroom for a minute, and then I'll be back to think through this again. Ah! Sequence arrays are not mutable. Interesting. Well, I'm going to let this run. I'll be right back. Okay, so I come back to an error, such as that is the way of things, I see. Inconsistent shape. Seriously? All right, let's build this idea out in the REPL. Okay, so let's start it over. Def B is new m/new array nd array shape. Yeah, shape. Let's do 300 by 300. Okay, easy enough. So B let me def ASDF is comp that with array FREP A. ASDF, let me try wrong number of arguments passed to render point 2. So comp only works on singularity functions, I guess. Where's the cert? There it is. Comp. The returned function takes a variable number of args. It applies the rightmost of the functions to those arguments, the next function to the result of those. Okay, so I can't. So I have to do. Well, I can do that if I modify what this function returns here. This array FREP, I can just make it return. Well, it won't match. Right, I could make it return point. This doesn't feel like the right approach, but I'm just gonna follow it through, just for the sake of it. Yeah, then this does have to be like this. And now if I def ASDF as that comp, oh, did I go too far? Now this form should kind of work. Oh, of course this is silly. This has to be like this on the inside here. There we go. That should fix that. The point and then some distance value. There we go. Okay, so right, so B is a matrix, ND array matrix. Good, good, good. Let's now just immediately modify it with def C as m/emap indexed of comp. Oh, no, let's just do ASDF because I already made the comp there. Over B. Too many arguments to def. Oh yeah, of course. This has to be like that. I don't understand why that can't convert to a persistent vector array. Inconsistent shape. Well, okay, so let's take a step back then. Will this work? So B is a mutable array, mutable ND array. I should be able to map indexed array FREP over A. Okay. If I turn this back into this. Okay, so that works. So it's related to trying to wrap things in vectors and whatnot, I guess. So is C now... Oh, something. I did something wrong here. Shape of B. Whoop. Why did it reduce it to just a shape of 300 like that? This is genuinely a little bit baffling to me. So what I would have thought would happen is if you just do emap indexed over B, I thought that you would get the same shaped matrix out of that, and I don't know why that doesn't happen. Because it should just be a 300 by 300 array containing distance values. That's what I thought it would be. Although now that I think about it, no, I do need. If I do first of first B, oh, wait a second, isn't it? Is it because... Am I just thinking about this all wrong? Let's def B as an empty thing. Now if I do first of first B, it's nil. Oh. Right. So if I do... Right, it's mutable. So I think I'm starting to understand what I'm doing wrong here. Right, so it's mutable. So this is the wrong way to do it. So grid is some mutable thing. So what I actually want to do, I don't want to map, I want to do to grid. Do to grid. What's do to? I think this might work. Right, so I built the grid, do to grid, this function, which is, how does do to work? I've not done that before. So do to is not the right thing here. Okay, let's just back this up here. Right, so So doing, let's see, okay, right. All I actually want, this is all I want to happen. This can be back to, okay, this is just, I don't even need array FREP. I don't need it. So this is what I want to happen. Pixels inside here pixels is like this. Then we just do emap FREP over pixels. That mutates the pixels, puts in their place. Oh no, I do need it. Sorry, emap indexed. I do need this. Array FREP of FREP gives me, it puts into pixels all of the right. That should be good. And now I just do render point 2. Over pixels as well. So that's pixels. They're modified. They should be at this point in exactly the state that I want. So I should be able to, I don't need this due to grid thing. I don't need any of this junk anymore. Okay. It should now work if I just do something to this effect. Right, I should be able now to do something like this. So I should now apply concat. No, sorry, let me. So those are the do. Let's build another let inside here. I don't know if this will automatically convert it back into what I expect, but we'll see. All right, let's see if this will actually work. Cider show 2A. I want it to actually render at least. It doesn't need to necessarily be quick at this stage. It's using mutability, so. Ooh. It's a real shame that. So let me just convert this to only return pixels. And let's do okay, so it's wrong already. the mental model in my head, it must just be wrong with this stuff. Okay, so ASDF, let's do first M shape of ASDF. Okay, so at this stage, what I've done to the array, so I made a mutable array here, and the only thing I've done to it is map the functional rep over it. So if I do first of ASDF, what I expect to see is a scalar, like just a single distance value, and I think it'll be negative. It's very negative. It's almost 0. So what if I do last of last? I think it's very big. Okay. All right. So well, right. So what if now I do hey Mike, how's it going? Hope you're doing well on this lovely Friday. I'm doing well. Just to answer your question, how are we doing? I'm doing well. Hopefully other people are doing well too. We'll have to see. It's a Friday, so usually people are in good moods on Friday. Doing all right? Haven't been getting notifications? So I haven't been changing my notification message. I wonder if Twitch stops sending notifications out if they've noticed that the text hasn't changed. So I'll start changing the text around again and see if that goes away. Because it's I mean, unless you have, let's say you have an iPhone and you've configured your notifications in such a way that you just basically never get them. I don't know. But I'll keep that in mind, and I'll edit my stream info. I'll edit the message more frequently, because that might, I don't know, it might have something, maybe like anti-spam prevention stuff. I don't know. We'll see. We'll see. All right. So if I were to do emap clamp, oh, util/clamp, of course. Hey, whoa, whoops. It worked. Well, you're on Android, so it's not an iPhone setting. Yeah, who knows? Yeah, I don't know. I don't have an easy answer for you, unfortunately. Oh, I made the mistake of just printing a huge array into the REPL, so that's my bad. I do that from time to time. Maybe what's happening is when I run this render.2 function over the array, it's returning vector data structures. And what I wonder is if it's like an object, but it's represented just by vectors, so it's throwing off the shape of what the array was before. Because if I do matrix shape of something like that, see, the shape of that vector is a it's a 1 by 1 by 1, 1 by 1 by 1 by 1 matrix, right? So here, if I do shape of model circle 20, forge dot model, yeah, it has a shape of 2 like that. So it's when I nest the circles inside, if I have that as an object inside of an array, then it's throwing off the shape of it. So I think that might play a factor in what's going on. So let me see if I'm right about that. Change it. I'll just wrap it in a map. Because a map will not mess up the shape. But that means I have to do this differently. So let's try this again. Okay. So if this works, I expect, ooh, it didn't fail. That's good. So if I do shape m/shape of ASDF, I expect it to be 300 by 300. That's promising. And if I do first of ASDF, there we go. We get the map with the pixel data in it. Okay, so that, now we're getting somewhere. now we're finally getting somewhere. So at least I think we're getting somewhere. Right, so at this stage, so I do those two things to the mutable pixels, then just make a little let. Oh, this is indented wrong, but that's okay. There we go. So let the sequence of pixels be the result of filter sum apply concat to pixels. But actually what I have to do first is, what's the value in having that 300 by 300 shape? Oh, it's a 300 by 300 array. Shape just refers to the shape of, I say array matrix, so it's a 300 by 300 matrix. So in this particular case, it's because I'm trying to render an image that's 300 by 300 pixels. The word shape in this context does not refer to a geometry. It refers instead to the dimensions of whatever matrix you're looking at. So M is aliased, it's Clojure core matrix. Shape, whoops. If I do this, if I make a 2 by 2 matrix, the shape is 2 by 2. Yeah, so it's meant to represent each of the pixels in the image. That is correct. So I already, Mike, I'm not sure if you've seen this. You may have. I have a, I'm using as a testing shape. It's a functional rep shape. It's a function of 2D points, and it returns a scalar distance to the edge of whatever shape you're drawing. I've made a naive implementation of a rendering function for these things, but you can see it's taking a little bit of time here. So what I'm just playing around with is different ways to see if I can optimize the render time so I have a little bit of a faster rendering approach. That's what I'm attempting to do today. I hope that makes some sense for you. So here, let me do another subtle example, let me do another example. If I do cider show, let me think. I want to do a circle. Let's just do a circle. Circles are nice, right? Radius 150. Again, this is clearly slower than you want it to be. Yeah, working on catching up from missing streams here and there. Yeah. Yeah, it's always okay to ask questions, clarifying what I'm working on. So you can see here, right? That is a circle. It looks nice, if I do say so myself. But so that is these three things here. I'm using parallel map here, but it's still, this is the slow part here. So it creates a grid of whatever size you want in pixels. Then for each pixel, it parallel maps the FREP function. So the time it takes will scale with the size of the image you're trying to render. So I want to just try and get this part to be much faster. And so I'm playing with mutable arrays in the matrix library to see if I could build a faster pipeline. And if I can get it working here, the next thing to do is swap out the matrix implementation for a different one that is faster. So the implementation I'm using right now uses default Clojure data structures, and it'll work Clojure and Clojure script. But if I can get the pipeline to at least work okay, for some definition of okay, then the next thing I want to try is install a different matrix implementation under the hood. It'll look exactly the same in Clojure. All I have to do is set implementation to some different backend, and then hopefully get much faster calculation. But I don't know what I'm doing. This is the first time I've looked at these libraries, so it's really a bit of fumbling, a bit of learning, you know, that kind of stuff. Hopefully that makes some sense. By the way, this, like, the fun thing is you can do, if I change the render function itself, you get different looking results. I should have probably made this circle a bit smaller, but it's kind of fun the way it is. So you see that there's a fuzziness there. So that's because you can, every pixel, once it's all calculated, it has a float value that's some distance. So you can make the color and opacity of the pixel dependent entirely on that distance, right? If you have it if you've calculated the distance in a whole grid, what you can actually do is map over subsections of the grid. So you could make any one pixel a function of not only its own distance value, but distance values of its neighbors. So you can start to really make some cool image things with it. This, right? This is purely based on just thresholding with the single distance value. There's even more cool stuff you could start to build beyond that, right? You can turn off the inner fill if I do this, right? If I do, well, I mean, if I entirely get rid of this, if I just comment it out, you can get a completely empty inner part of the shape. Transparent in this case. There you go. You can make this a ridiculous number here. So there's fun stuff to do, but I want it to be faster. That's the whole thing. It's too slow. And I mean, so this like this doesn't scale at all nicely to 3D functional rep, which is really where I want to use stuff to get good visuals, right? Like it's fairly easy to, at least for me, to picture 2D stuff in my brain, right? So if I'm making 2D manipulation functions, oftentimes I can be fairly confident and just render one thing here and there to figure it out. But 3D stuff, it's really nice to check things more frequently. But if it takes way too long to render it, that's kind of useless, right? So that's the motivation here. So many fancy knobs to turn. Yeah, totally, right? It's really it's fun, and I want it to work in different ways. So you can tell, right? The design of these functions isn't good, right? I'm literally redefining the render function itself to configure it. So there's obvious room for improvement in a few ways, but I don't want to optimize the design until I've optimized the actual implementation underneath the hood, right? So here I am on a Friday trying to learn things. I say that like it's a bad thing. I'm having a good time. Boom, there's a circle. Love it. Love it that way. All right, so back to this one. Lost my train of thought on this one, to be completely honest. Right. Oh yeah. What I've been doing, so this render function here now returns, right, so if I do, I still have ASDF defined, first ASDF. What I need to do is just change up this last bit here. So filter sum won't work. Well, yes it will. What am I talking about? And then I actually want to do this. I want to do, I don't think I need to p-map this, but why not? Get a little bit of parallelism in there. The other thing I haven't learned properly yet, and it's on my list, is I want to, so right now, when I'm trying to get a bit of parallelism, I'm just changing map to p-map. P-map just means parallel map. So it's really cool if you've got a function that you know might take a while on a single value. You could just, and you've got a huge list of calcs to do right over it. You can use pmap to get parallelism for free out of there, but it's not a like, it's just there for you, right? It doesn't, there's no guarantee that it'll match your design requirements or be a really good way to implement things. So I want to learn proper ways to start architecting parallelism and concurrency on my own using things like core async. I don't know how to do that stuff yet, at least not beyond like tutorial level. So that'll be another thing to dive into. So there's all these little tools and packages. I don't know which combinations will ultimately result in a fast implementation, nor do I know if I'm thinking about this the right way. But at the very least, I've learned how to use some important libraries in the process, right? So kind of can't lose. Sounds like it could be a tough topic. Yeah, that's why I haven't really used excuse me. That's why I haven't used it all that much. Because one, I haven't really discovered a spot where I know I need it, and two, yeah, I'm intimidated by it. But Probably once I sit and learn it, go through some more tutorials, try to design my own stuff with it, it'll actually, I have a feeling it won't be quite as bad as I think. I just have to wrap my head around the idea of channels, buffered channels, futures and promises, and how to use them properly, all that kind of stuff. It might be tough, but I do really think it'll completely be worth it. And then once I've got a good mental model of how to use it, I'll know way better where to use it, where not to use it, that sort of stuff. My confidence will hopefully just increase a bit. We'll have to see. Okay, so now the moment of truth again for this. Let me do... let's try get that polygon rendered with Cider Show 2. See, you can tell intuitively that my implement, well, one, it doesn't work, and two, it's not faster. I did something wrong. Oh, this has to be S pixels, not pixels. What a goose. What the goose. It worked. Okay. I know why it's only showing the corner like that. That was something I knew would happen, and now I can work on fixing it. Okay, so I have to do a shifting approach here. And I don't think it felt faster, but I don't think it's going to be faster. First of all, the size of this array is not the same as the size of the array for the Cider 1 version. So I have to make it 400 by 400. And the second thing, I have to... right, so the reason it's doing this is because the FREP function is centered at 0, 0. But I'm just doing emap indexed, which means I'm passing into the function, the point is just defined by the indices of the array, which start at 0, 0. So the top corner here is the 0, 0 index. The bottom one here is the, it's bigger than that. It'll be 300, 300. But what I actually want it to be is negative. I want it to shift over. So there's two ways I could do that. I could shift every point back, or I could cheat it for the time being and actually do translate, which I can translate A like that, and I get a new FREP function out of it, so it works just fine. So let's translate FREP by wonder if it should be 199199 technically. I don't think it'll matter, but let's go. Wrong again. Oh, that's a syntax thing. It's my bad. Oh, my bad. There we go. Any plans for the weekend, Mike? I'm actually just thinking now about what I'm going to do this weekend, and I don't actually have an answer. Might go on a bike ride if the weather's good. I hear it raining outside at the moment, but the rain never has a tendency to stick around too long, so there's always an opportunity. Ooh, I did something wrong. Oh, isn't that fun? I believe I'm supposed to shift this. No, why is that wrong? Let me back this up here and just do an FREP shift of 1010. See if that actually is moving things the way I expect them to. Nothing too crazy. Got some dependency issues in some of your personal node projects to upgrade. You're going to try your hands at building a soccer training tool. A soccer training tool? Tell me about that if you want to, if you can. That sounds really cool. Oh, I think I'm translating exactly the opposite way that I'm supposed to, which I think actually might be a mistake in my translate function, but we'll check that later. Is it for your own training, or are you some kind of, like, do you do coaching? It sounds really cool. It sounds like a great project. Sounds like a ton of fun. Reminds me of a project I've been meaning to get to with my cousin, building a tool that helps you, like, that derives from some questions, a training program for bouldering and climbing. Okay, we have two rendering functions that I can start to compare, hopefully. Let's get some time value for this. Then we'll get some time value for the other one. And then we'll just run it a few times. And that's a really bad way of benchmarking. But when I'm benchmarking two bad functions, do I care? I don't know. If I can make an order of magnitude assessment, that's helpful, right? Basically, the question I have in my head is, am I saving myself time or not? And I actually think I'm not, which indicates that I need to work on this. But we'll see. I shouldn't get ahead of myself. Oh yeah, look at that. Okay, so this is 2 times slower. Now, to be fair, let me adjust things so they're actually rendering the same way. That's a needless distinction here. R of 1, everything else is the same. Let's go again. Didn't coach this year because of the pandemic. Naturally, that makes sense. Personal thing, all your soccer mates have kids and no time to train with you. It's a ramp. It's basically a ramp that will launch the ball back to you when you kick it. It's a link to the item. Easier than explaining. Yeah, that's fair. Want to make it because you like building. Okay, so when you said soccer training tool, because we're talking software at the moment, I was totally thinking like some kind of app that like helps you make a plan. What's it called? Football Flick Urban Trainer. I opened it on my iPad, so this thing, right? I think. Looks about right. Yeah. So you kick it, aim for the bottom of the ramp, and it flicks. It's like gives you a nice old Tony Hawk Pro Skater situation, and you can do a header. Oh, you can use these arrows to kind of pass back to yourself. I'm guessing something to that effect, and then it catches it if you miss. That's pretty cool. But you're gonna make your own. I dig it. That's a great project. That's super cool. Oh, you have ideas for soccer software too. Want to basically be able to input data, show a rendering with X's and O's about certain scenarios. Oh man, You could be like a super high-tech football coach. It's pointed backwards a bit so it throws the ball towards you, which is nice. Yeah. Man, that sounds like an awesome weekend right there. I mean, you might have put together that I too love building. So I 100% support this project of yours. That's really cool. Unfortunately, I am loath to admit that I haven't built anything in quite a while. I don't know. I think I got to rework my schedule to give myself the time I need to get those creative juices going for design and stuff like that, you know? I've been in the weeds of trying to make 3D software, and unfortunately that's put a bit of a slowdown in my physical making time. But that's a scheduling problem. I'm thinking it'd be fun to do something with these wooden boxes here and a TV screen, so I could have some kind of cool display thing going on behind me while the stream's going, so that you don't just see my mattress. But that's just thoughts in the back of my brain, you know? So I've spent this whole time learning that, at least with my current understanding, doing the array approach is actually slower than just doing parallel maps on immutable data. So, next little thing to check is... I can switch this approach around a little bit. I'm going to make Cider Show 3 quickly. I'm curious if making an immutable array and just threading it the way I'm used to might be helpful. Is that what that is? I thought it was a little external closet. Oh, so these are two plywood boxes that I made when I was in Ontario. I had 3 total. I loaded all of my stuff into those boxes and screwed a lid onto them, another piece of plywood. And I put 3 of those boxes into my Dodge Journey and drove across the country, unloaded the boxes, and the intent is to have the boxes as materials for building little bits of furniture as I need it. In fact, the desk I'm using has one of those boxes as its base, and the lid, the top of my desk, I can open up and use the inside of it as electronic storage. The desk itself, I do plan to improve the design of it, but that's the whole point of those. It's just cheap plywood, but it ends up working reasonably well, and it accompanied me and my stuff across the country, which is pretty neat. But it, little external closet, it does, like, I've got all my textbooks that I mean to read through again in there, so it's storing stuff at least. The cool thing about making stuff out of cheap plywood is that if you're renting, especially, sometimes, you don't want to drill into or change up the walls, right? But if you make some plywood stuff and sturdy it up a little bit, I could mount stuff on there. I could do whatever I want as long as it's stable enough, and that's a design problem. So it's fun material to use, because the cost is low enough that you're not afraid of ruining it. The only real downside is it's not aesthetically the best. You can fix it up quite well. You put some stain on there. You could I don't know. You could get creative and you could draw on it and stuff like that. Oh boy, I went on a whole rant, and that's not what you meant. You meant that the mattress was a closet, like one of those soft covered stand-up closets. Yeah, no, this it's the closet's right here. So that's another thing I really do want to improve. The bed is comfy and there's enough room during the day. I just put that up and I can do whatever I need here. And the rest of the house is perfectly fine. But I want a better solution for this as well. Either something with wheels or some kind of loft bed or something. But I can sleep comfortably every night. I have the bedding in the closet too, so I just make it up nice and quick. But yeah, not the most glamorous in the world. But hey, I'm not a man of glamour anyway, so here I am living my life. It's a pretty neat thing. They do that stuff in Japan, mini homes, which is fascinating. Yeah, I actually, the concept of living in small spaces is actually kind of fascinating to me. It like if I could snap my fingers and get anything I wanted in the world, what I would love is to buy a property that's empty. Nice forest and whatever. It's a nice looking place, and I would build two things on it. The two things I would build are one, a tiny home, a single floor thing, open concept, probably picture like a really nice looking but small studio apartment with nice windows and stuff like that. And I would just make sure that there's good windows that you can open it up, and during the day in the nice weather, you're basically outside. It's almost like you're living in a really fancy gazebo. The second thing I would build is a nice shop where I could start putting lathes, putting robot arms, building stuff like that, and just live my life in a place like that. Ooh. It would be gorgeous. But the buildings themselves would be only as big as they need to be, and outside would be like the important thing, if that makes sense. That's what I would love. I being inside isn't bad. Shelter's a really important and good thing, but I don't know, like sometimes it feels like we shut the beauty of the outside world away, and I want to be part of it. But I'm waxing poetic about a house I do not have. And you know what? I'm a happy man wherever I live, as long as I'm fed and can exercise, can see friends. I don't need to live in the fanciest place in the world, you know? But that's just me. All right. Last thing I'm going to do before I get going for the weekend is just try this immutable version of the matrices and see if I get see what happens. Okay. So, to do that, I actually get rid of this do scenario here, and I can just, so I have let pixels, so let's thread pixels through. Mansions are overrated anyway. The rich folks are welcome to keep them. Yeah, it's they're not compelling to me in any way, honestly. Maybe the front foyer of a mansion probably looks really great, but you know, yeah, I think you're right. Mansions are overrated. Don't need them. Have you heard of the term McMansion? It's like Mick as in McDonald's mansion. They're like big homes that people build up in like really rural areas, usually like in highly industrialized farm areas. But what you can do, right, if you're a farmer, you can you have your whole big property, right, and I don't know what the rules are exactly, but you're allowed to designate certain portions of your whole land for a residence, and then it's actually relatively cheap to do that, and then it's out in those remote enough areas, it's cheap enough to get build permits to build bigger things. and you've got tons of land to do it on, right? So people like to build these ostentatious things, and you call them McMansions because it's like the Happy Meal of of expensive homes. And it just, I look at it and I'm like, I understand why someone might be excited to build something cool for them to live in, but it's just not for me. If I had that kind of land, I wouldn't want to share. I mean, like it's their own land for their own home. Usually, it's not like they're selling off to contractors so that they can build and sell off houses. It's like, I'm the farmer. This is my plot. By the way, township, this here is where I'm building my home, and over here is one other home for my main farm hand person. So you could do that. Like you don't have you don't just, as far as I know, you don't just chop off your land and let other people home for a worker. Yeah, kind of like that, or for yourself. So nothing crazy, but that's where I've heard the term McMansion referred to before. Kind of crazy to me. I also don't know like how, maybe that's just like only the people in my hometown use that word. Maybe it's not like a common thing. I could be just talking like a fool over here. All right. Let's see. Oh, I want to turn this into a comp. Right, so what do I do here? Here I do I'm gonna make this just a little easier to read here, I think. So let F be comp. Yeah. Right. I'm just trying to think through how this actually has to work. I need the point in the render function, but I need the distance in the render function too. So I have to do array FREP first. So I need a new array FREP function that has a different return. And the return is going to be a map. No. Let me think about this for a second. Let's not complicate it this way. I think I can do it this way. Let's not overcomplicate it with this right now. I'll just do, let's change F so it's just going to be translate FREP -200. Okay. Now, pixels get mapped. Thread last, right? Yes, we're getting somewhere here. So, right, so this, you take your array. For each item in the array, you map the functional rep over it. So you get back the same shape array with all of the distances computed. So it's full of floats. Then you can take the result of that and thread that through emap indexed. The same function here, render point 2, I don't need to modify it because it is a function of the index, which is a 2D thing, and then the distance, which is computed, which will be the value in that position. So that is all good. Oh, I get rid of pixels here. So I map this function over pixels, then the result of that gets threaded into here. So the result of this whole thing is now, let's see, what's the, yeah, so at this point, it should be good. So I should actually be able to thread the rest of this kind of logic into here. So, right. Apply concat is that part. Then filter sum. Now pmap result. Sequence pixels is this whole operation. And now we can close that off like this. Like this. All right. I'm nearly there and then nearly good for the weekend. That's the name of the game today. All right, let's just double check that we've got the right approach going on here. This I don't know about, but maybe not a problem, maybe it is. So then I just check when it's empty, it'll return nil, so it'll never try to render something that doesn't exist. Otherwise it'll cider show the results of that. All right, let's give it a shot. Cider show 2 took about 24 seconds, I think it was. Let's see how long this takes. First of all, let's see if it works, and then we'll go from there. I think this entire process might be something really cool to make into a video. Ooh, that actually, I mean, it's slow. I don't know why I was happy. I think it's slow, still way slower than my original PMAP version with Cider Show. Yeah, it's double. It takes double the time. Oh man. Well, that's just not gonna cut it. It's just no good. Something learned. Oh, totally. I'm extremely happy with how I'm doing this. I love what's going on. The impatient part of me wants a fast renderer right away without any effort. But this whole thing, right? So as I'm going, I'm just appending numbers to these, right? And what I think I want to do actually is save this out once I get some good solution. I want to save this out to its own little project, make some notes, and maybe turn this into a video where I'm explaining how I went through it, because I feel like that could be pretty valuable for people. Okay, but we've got good progress, honestly. I've got two versions of matrix-based versions that I can then, the next thing I want to try with the matrix stuff is, if I pop into the wiki here, code optimization and thinking of ways to eke out better performance is a very cool topic. I'd watch a video about that. That's good to know. I think I'll definitely have it on the production pipeline. Makes it sound fancier than it is. I'll put it on a list of videos to make and probably prioritize it because it's on my mind and it feels like a fun one to make. So that's usually a good sign of a video that'll be good. Okay. Right, I'm going to get going very soon, but I want to find, here it is, matrix implementations, right? So here are some implementations just built into core matrix, sequences, ND array. This is what I was playing around with Cider Show 2, a mutable array, storing objects of any type. Double array, I don't think it doesn't really pertain to what I'm trying to do. And then persistent vector presumably won't have any speed up because it's using regular Clojure stuff. But these two things here, a wrapper over JBLAS, I don't know how to pronounce that. This seems like a good thing to install and see if I get speed ups from that. So that'll be something I try later on. Stick with production pipeline. Dig in the super fancy terminology. So in fairness to myself, part of, like, I build up every video I make, I use FFmpeg in slightly new ways. So I'm building up these functions in Clojure that automate little bits of my video production. So it actually is turning into a pipeline in an actual real way. There's just a lot of manual stuff / me needing to be better at time management, and that's still all in meat space, not in silicone. Anyway, I've been actually going. This was a good stream. I enjoyed myself today. Before I go, I want to say the last couple of streams, they've been quieter in chat. So if there's anyone who can help out with spreading the word, sharing the stream around, or anything like that, please do so. I like streaming whether or not there's an audience at the moment, but it's always really fun to share my work and ideas with people who are engaged in the chat. So sharing the chat, or pardon me, the Twitch stream and the YouTube channels and all that stuff is always super helpful. If anyone's compelled to do so, please do so. It would be awesome. That's all I've got to say promotion wise. Just thanks everyone who does tune in, whether or not you chat. I do really appreciate the audience, and I hope people stick around as things grow. You know, if it takes some time, that's cool too, but I just love doing it. So anyway, that's all I've got to say. I hope everyone is try to get the word out. Clojure Army will rise. That's right. Get the Clojure crew in here. All right. Thanks, Mike. I always appreciate your participation and the fun in chat with you. So it's fantastic. All right. Have a great weekend, everyone. I'll be back again on Monday. That's all. Goodbye.